Okay, graphs of sinusoidal functions. So remember, we've got this equation, y is equal to a sine bx plus c plus d. And just to review what that looks like. So here's kind of a basic sinusoidal function. It's actually been shifted down 1 unit. D is -1, so we can see the middle, or the midline, is down 1 unit because I've drawn the midline in here. The amplitude, which is the distance from the midline, the a value, so from here that's 1, 2, 3 units. Okay, or from the midline going down 1, 2, 3 units is the amplitude. Or you can count from the max 1, 2, 3, 4, 5, 6 units from maximum to minimum, and the amplitude is a half of that. So half the distance from max to min. Whereas the midline is halfway between max and min. The b value is 1, so our period here is 2 pi. And that's kind of your basic, and there's no phase shift. So see the c value will shift the graph to the left or to the right. Okay, just take that back to not shifted, and the d value moves the graph up or down. In this case, it's up 1 unit. And the a value changes the amplitude, right, which is the distance from the midline to the max or the min, whereas the b value changes the period. Okay, so back to this. So if you want to find the midline, which is in the middle, then the equation of the midline. So remember, when we say equation of a line, it needs to be y equals. So if you take maximum plus minimum and then divide that by 2, you're basically finding the middle or the average, right? So the midline is the average. The median value, so relating to this equation, the median value is d, which is max plus min minus 2. So d is max plus min over 2. And if you want the equation of the midline, it's y equals that number. And otherwise, the median value is d is that number. For the amplitude, it's max minus min, so it's half the distance between the two. If you take the maximum and subtract the minimum, you get how far apart they are, and then you divide that by 2, half that. Or the distance from the midline to either the maximum or minimum value. Period is the length of the interval of the domain to complete one cycle, the length of one cycle. If the equation has the b value in there, then the period is 2 pi divided by b. And it also works out, if you rearrange that, that b, not great b, is equal to 2 pi. Oh, hang on. I'm trying to use the mouse to draw instead of the tablet. So b is equal to 2 pi divided by the period. And the start point, and we'll get into the start point in a minute, is negative c over b comma d. So let's take a look at a couple of applications. So the first one, we have a Ferris wheel. So everybody's familiar with a Ferris wheel. So you get on at the bottom, and you ride up to the top, back down to the bottom, back up to the top, and so on. So the graph below represents the height of a person on a Ferris wheel over time. The person gets on the Ferris wheel at x equals 0, so we're using x and y. And that's a time of 0 minutes, and y is the height in meters. So it says, what is the height of the Ferris wheel when the person first gets on it? So we need to figure out what this scale is. So 2, 4, 6, 8. So each of these ticks is 2. Okay, and this is a height in meters. And this is time in minutes. Time in minutes and height in meters. So when a person first gets on, they're getting on it at a height of 2 meters. Now, anytime we're answering questions that have to do with the y-axis, we're talking heights, and it will be in meters. And anytime we're answering something that has to do with the x-axis, we'll be talking minutes, time in minutes. So there are units associated with each axis. What's the maximum height of the Ferris wheel? So we can see here, one tick above 80 will be 82 meters. What is the radius of the Ferris wheel? So we think about radius of a circle, it's the distance from the center to the outside of the circle. So we kind of want to know, where's the center of this? And the center is actually the d value, right? The middle. And d is max plus min. It's the average over 2, which will be 82, the maximum, 2, the minimum, over 2, which is 84 over 2, or 42. So we have, and I'm just going to sketch that in. We'll do this in red. So at 42 meters, that's d. D is equal to 42. And we'll sketch this in as best we can. So that's our d value. So what is the radius? Well, it turns out that in sinusoidal, the radius is actually the amplitude. So how do we get amplitude? Okay, because the radius is the distance from the middle to the max or to the min, right, is the radius. So for us, that's the amplitude. And the formula for amplitude is max minus min. So the difference between them, that's how far apart are they. So 82 minus 2 over 2, which is 80 over 2, which is 40. Okay, now the d is in meters and the a is in meters. So a and d are horizontal axis units, right? Because a is this distance and d is this height here in the middle. So what is the radius of the Ferris wheel? It's 40 meters. What is the height of the person after 1 minute? So in 1 minute, we will, it looks like we're just going to reach the middle here. So that's 42 meters. How long for one revolution? So that's starting at the bottom and getting back down to the bottom. The Ferris wheel will have gone around once. So that's 4. But this unit, any numbers we give that relate to this axis are in minutes. So 4 minutes. What is the amplitude of this sinusoidal function? So an amplitude isn't going to have units on it, but the amplitude is the radius. Right? So anytime you're dealing with any wheel, the amplitude of the function will be the radius of the wheel. It's the equation of the midline. Okay, so equation of midline has to be y equals. Okay, and that's going to be the middle, so that's our d value. So y is equal to 42. Right? It's also fair to say that d is equal to 42. Right? D is 42. A is 40. What is the period? So the period is the amount of time it takes for one revolution. So that's 4 minutes. The equation of this sinusoidal function is y is equal to 40 sine pi over 2x minus pi over 2 plus 42. How do the values of a, b, and d in this function relate to the context of this example? So this is a. So a is equal to 40, and it's the radius of the wheel. So radius of the wheel. So our a value is the amplitude, but that's the radius of the wheel. The d value, let's do that next. So d is equal to 42. So that's the midline or the median height. Well, the middle of a wheel is the hub. So this is the height of the hub. Okay, or the axle. Right, so you think about a wheel or an axle. If you've seen a bicycle wheel, you've got that little axle in the middle, or on your car tire, the car goes on, the wheel goes on the axle. That's the height of the axle, the hub or the axle, right? So it's the middle of the wheel. Middle of the wheel. Of the Ferris wheel in this case. So Ferris, which is capitalized, that's a proper name because the guy who invented the Ferris wheel is named Ferris, George Ferris. And this actual Ferris wheel, these dimensions here are for the first Ferris wheel, which appeared at the Chicago Exposition back in the late 1800s. So if you Google Ferris wheel, you'll see this original Ferris wheel. And it's actually a pretty big, it's a pretty big wheel, right? It's going up to 82 meters high. That's a good chunk of a football field. Okay, now the B value, so I'm going to extend the page. So B, not the period, right? B is not the period, but the period. So if I have a B value and I want to get the period, it's 2 pi over B. So for us, it's going to be 2 pi over 2. So if I'm dividing by a fraction, it's going to be 2 pi times 2 over pi. And the pi's cross off, and we get 4. So the period is 4, and period has units, it's 4 minutes. Okay, so the B value is not the period, but we use it to calculate the period. So use to calculate the period. Calculate the period. So that's how A, B, and D relate, right? There's actual physical quantities or meanings in the context of this question for A, B, and D. And you'll find that with anything, if we just give you an equation, then the equation we can only talk about other terms. We'll do that in the next lesson. But for here, it's not just an equation, right? Or sorry, it's not just a graph, because today we're doing graphs, tomorrow we'll be into the equations. But here's a graph. From the graph, we can get all of this information. We can get D, we can get A, we can read the period, and from those we can get A, B, and D. All right, let's go on to the next page. Tidal depths. So this one we don't have the graph, but we have information that will allow us to get the graph. So let's take a look at this. In Inverdeen Harbor, the maximum depth of the water is 22 meters. Okay, so this is depth in meters. This is time in hours, occurring at 1 a.m. and 1 p.m. So 1 a.m. 1 p.m. is 13 hours after midnight. So this time is time after midnight. The minimum water depth is 6 meters. Okay, so there's 6. Right, here's 22. Occurring at 7 a.m., 5, 6, 7. And 7 p.m., so to get that after midnight, would be 7 plus 12 would be 19 hours. So either using the 24-hour clock, we would say it's 19 hours. The depth is 14 meters. Okay, so that's here, 14, at 4 a.m., so 4 a.m., 10 a.m., 4 p.m., and 10 p.m. 2021, 22. It's kind of faded out here a bit, but and 10 p.m. Assume that the relationship is a sinusoidal function. Okay, so on this, connect the points to draw a sinusoidal function. Okay, so we start here. So remember, it's split into 4 parts, and each part will be, so this is from the maximum to the middle, to the min, back through the middle, to the maximum, back through the middle, to the minimum, and back up, and so on. I'm just going to clean up that first bit. See if I can do this. Okay. And then on this side, of course, it would just be heading back down again. So calculate the amplitude period and the equation of the midline. I always like to start with the midline. Okay, so let's calculate that. So D is the average, right? So the average is add the two together and divide by 2. So we have a maximum of 22, a minimum of 6, divided by 2 is 28, divided by 2, which is 14. So D is equal to 14. Right? That's 14 meters, right? Because our height's in meters. So actually, they gave that to us, right? Here's the midline. I'm just going to sketch that in. Dot that in. So that's the midline. So the equation of the midline is y equals 14, right? Y is equal to D, and D is 14. Amplitude, A. Now, you don't get these formulas for amplitude, but you just have to know it. So it's max minus min. And you can actually count it off of the graph, right? I mean, you could just go 2, 4, 6, 8, 10, 12, 14, 16, 18. Oops, 16. So if it's 16 top to bottom, the middle's got to be 8. So just go 2, 4, 6, 8. There's my middle at 14. Here's my amplitude. From 14 to 22 is 8. Or from 14 down to 6 is 8, right? But we can also calculate that. So we go 22 minus 6 over 2 is 16 over 2, which is 8. Okay, so 8 meters for A. And if we're just listing the amplitude, we just go A equals 8. And the period, well, we can go from a peak to a peak. So we're going from 1 to 13. So that's 12 hours. You can also go from the bottom at 7 to the bottom here at 19. That's also 12 hours. Okay, so that gives us the period. So period equals 12. Now, so this equation can be represented in the form y equals a sine bx plus c plus d. So we've got a. Y equals 14 is the equation of the midline, but the d value is 14. The period is 12. B is equal to 2 pi over the period, which is 2 pi over 12, which will reduce to pi over 6. So we end up with B is 2 pi over 6. And now we're left with C. So that goes back to here, this start point. So what is the start point? Well, let's take a look at it on the Ferris wheel. The start point is defined as when the curve first meets the midline and the curve is going up. So for the Ferris wheel, this is the start point. So what you do is you go to where the y-axis and the midline intersect, and then you just follow along the midline to the first point on the curve where it's going up. So let's see if we can find that. Okay, and then we're going to use this formula, which I'll write down as soon as we get to the other, back to the other example. So I want the midline and the y-axis, and I want the first place where it goes up. So that's here. So this is my start point, which has coordinates of 10, 14. So let's take a look. How do we figure out then? How do we get this C value? And actually when we do, we'll graph it and we'll see if our graph matches this graph here. Always, that's one thing I like about sinusoidal is that, you know, given some points, because really what were we given, right? We were just given a number of points when a curve was at its maximum and at its minimum and when it reached 14. From that we sketched a sinusoidal graph. From the graph, from the max and the min, we figured out the D value and the A value. Looking at the graph, we figured out the period. And using that, we calculated B, and we found the start point. So we know the start point 10, 14. So from the formula above, the start point is negative c over b, comma, d. Well, that's 10, comma, 14. So d is 14, so that's no surprise. We already know that. But that means that negative c over b is equal to 10. Okay, so let's take a look at this. We know what b is. Right, it's pi over 6. I don't know why I put a 2 in there. It's 2 pi over 12 or pi over 6. So first of all, let's get rid of the negative. So let's solve this equation for c. So we'll multiply both sides by b. And then we'll multiply both sides by negative 1. So c is equal to negative 10b. So c is equal to negative 10 times pi over 6. And we'll just keep this as exact value. So we'll reduce the 10 over 6 and get negative 5 pi over 3. Okay, so 10 divided by 6 is 5 over 3. So here's the equation that we're going to put into our graphing calculator. Y is equal to a sine b, so we'll just use pi over 6, b, x plus, oh, only it's not plus. Let's see if I can undo that. Okay, so hang on. Pi over 6. So that's our b value, x minus 5 pi over 3 plus 14. Okay, let's pull up the calculator. Let's slide it over to the side if I can. Turn it on. So we do want radian mode, so we'll just get out of that. We'll go to y equals. So I'm going to put in the equation. 8 sine, bracket, I'm going to go bracket. So what I'm putting in would work on any calculator. Pi divided by 6x minus, and I'm just going to put this in brackets as well because it's a value, 5 pi divided by 3 plus 14. One other thing, I always like to show the midline, so I'm going to put in the midline of 14. I'm now going to set my window to match what's up here. So we'll go from negative 1 for x, negative 1, and we'll go to 24. And we'll do that by 2's. We'll go by 1's actually. So hang on, let's go by 1's. And for our y values, we'll go negative 2 to 24. So what I want to do is match this, right? So that negative 2, if I put these numbers in, 24, we'll go by 2's. So when I hit graph, basically what we should see, and I'll just move this up a bit, so we should see this exact graph, right? So we'll see a point at 122 near the top. So let's hit graph. So there's 1. That should be 22. And we can see we've got a minimum here at about 7. So there's our midline. So I always like to draw the midline in. Does it look like it's in the middle? And it does. So that's pretty good. 1, 2, 3, 4, 5, 6, 7. So that's a minimum. If I go second calc and put in a value of 1, right, then we know that we should get a height of 22. And we do. Same thing. What if I put in a value of 4? So at 4, we know that the height should be 14. So value 4, and we get 14. And at, let's put in 19, and at 19, so second calc value, if we put in 19, we should get a value of 6, minimum value, and we do. So I think it's kind of neat, right? Like if you look at what we've done here, we have some information. We use that information to plot some points on a graph. We had some maximums, some minimums, and some that turned out to be in the middle. We put a nice little scale on things. We drew a sinusoidal graph. And then what we did is we came up with the actual equation of that graph, right? So we worked out the middle. Max plus min divided by 2, and we got d is 14. So we got our d value. We then went max minus min, 22 minus 6 is 16, divided by 2 is 8, and that gave us our amplitude. So we have A and D. We used the period, which was 12 hours. So you can also do the period if you went from here back to here. So from, this isn't exactly a start point, but from here to here, that's from 4 to 16. From 4 to 16 is 12, or from the start point at 10 to the next one, which is going to be at 22, then that's also 12 hours. That's one period, right? So we're split into 4 parts. So in this case, and because the period is 12 hours, each of these parts is going to be 3 hours. It'll take 3 hours to go from the maximum to the midline, right? From 1 to 4. Another 3 hours from 4 to 7 to get to the minimum. Another 3 hours to get back to the middle. Another 3 hours to get back to the top, and so on. And this is actually going to be 2 cycles. So we got our period, and we use that to work out a b value, right? Pi over 6. And then we use this formula for start point. So that was using the formula, and I'll just hide things. Here we said negative c over b is going to be 10, right? The start point is, so we already know the d value. Okay, so solving, negative c was 10b, c was negative 10 times b. We had a b value of pi over 6. Okay, we put that in. 10 over 6 becomes 5 over 3. We get negative 5 pi over 3. That's our c value that goes here. And so the neat thing is, from plotting these points, we get an equation, and if we plug this equation into our graph, then we get this exact graph that we drew from the information that was given. So doing that, we now want to say, okay, so let's see if we can match. We have 2 graphs here, and say, let's see if we can match the graph with the information that's here. So I always like to start with the middle. So that's a 1, and that's negative 5. So from 1 to negative 5 is 6 units, which means 3 units from 1. Here's our midline, right? So this is d is equal to negative 2. And this means that a is 3. So I'm looking for a 3 for the a and a negative 2. So that's a possibility, and that's a possibility. So we have 2 possible answers, right? It could be f, it could be h. So the distinguishing characteristic is going to be this b value. So let's figure out, with this b value, the period will be 2 pi over b, which is 2 pi over 2, which is pi. And let's take a look at the period here. So say we go from here to here, and we can see that from there to there, based on this scale here, is pi units. So we know that this is graph H. All right, let's take a look at this guy. So it's a little hard to read, but it's got a maximum value of 1, and it's got a minimum value of, God, looks like negative 3. So halfway between 1, so those are 4 units apart, right? So negative 1 is going to be the middle. So I've got a d value of negative 1. Well, there's only one thing with a d value of negative 1, and that's g. So let's just verify the rest. Does it have an amplitude? So if that's negative 1, from negative 1 to negative 3 is 2 units, or from 1 to negative 1. Is 2 units. So that matches up with that. This says that the period will be 2 pi divided by a half. Well, we don't like to divide by fractions, so it's 2 pi. So we flip it, which will be 4 pi. So the period, the distance, say from here to here, should be 4 pi. And we can see that's 7 pi, that looks like 4 pi there. So we're just a little bit to the left of the 0, and we're about that same amount to the left of 4 pi. So that matches with the period of 4 pi. But really all we needed was the midline is at -1, was enough to distinguish this from all the rest of these guys here. So that is graphs of sinusoidal functions, right? So given a graph, you can get the equation of the midline, which gives you the median value, which is D. You get the amplitude, which is A. You can work out the B value. If you can figure out the period of the graph, the B value is 2 pi divided by the period. And then a little bit of math with the start point to get us the value for C. And once we have all of those, we can graph the graph and see if it matches up with the equation that we got. Okay, so we are done. And I just need to stop this recording.